No.
Hey, Coffee Compiler Club, short group today, and that's just what it is. So I put an AA update in the Discord, which I probably should copy into the doc. Um, and there's probably a way to do it here from Discord if I can figure it out. I'm going to do it from Emacs, and then I'll go talk it through because I think it has an interesting compiler. What do you call it? There's something exciting or interesting about compiler. So I threw a giant wad of text into the doc, which I will now share upon as soon as I find it. Boom. No, that's my email. How about this? Yeah, okay. So I threw this out this morning in like 5 minutes, so pardon the typos, all helpfully lit up inside the docs.
It was pretty impressive for 5 minutes.
Yeah, maybe it was 10. It wasn't any longer than that though. So there's this correspondence between stack frames and C-style structs.
Mm-hmm.
And I looked at it hard in the implementations that I had done before and we're doing right now with AA. And so some years ago, I figured I'd just go ahead and take that correspondence and run with it.
Increase the font a little bit.
Okay. And then how about now?
Yeah, good.
Okay. And here's Derek, who might be interested in this too. So now I'm like all paying no attention where I lost my train. Okay, here we go. So generally in this correspondence, so for Derek's version, I've done this in AA where there's a correspondence between stack frames and C-style structs. And C structs generally have a memory and a memory identity, a pointer. Sometimes you can ignore the pointer or explicitly not have it, like multi-values or multi-tuple returns or something. And then you expect those fields might get exploded into registers, say, as an implementation strategy. If you look at stack frames, they generally don't have a language visible pointer. You get at the fields by directly mentioning them, but the hardware uses a stack pointer under the hood for that. So there's always actually a pointer. And also we expect most of those fields get hoisted into registers since there's no aliasing because there's no user visible pointer identity notion, right? And fields here would often be called local variables and not fields. So other than the name change, the concepts are kind of similar. And then in languages that allow full use of closures, the stack frames can escape, not behave stack-like. Ignoring how useful that is, there are definitely uses for that that are actually pretty exciting. But if you do it all the time, it's pretty expensive, it's common. So you get into this zone here, and I'm going to scroll the video a little bit.
And this is why some languages heap allocate their stack frames.
Yeah. So they can do closures, and they don't have to think about whether or not there's an efficiency. They don't have to do an optimization to move it from the heap back to the stack. And some languages make the effort to go back to the stack, but they don't always get to if you've done a escaping like thing. It's like why Java lambdas have ensure finally. It guarantees they can have a stack-like behavior. So in short, they're both names. They're both mappings from names to types and values. Types at typing time, values at runtime. And the C structs are expected to live on the heap and have an identity, a pointer, but sometimes get treated as values and in register. And stack frames have the reverse expectation. They're expected to live on a stack with no identity and in register, but sometimes they escape to the heap instead.
One more example of activation record other than stack frame and closure and environment would be a coroutine frame.
Yep.
And you often also need to allocate coroutine frames on the heap precisely because of the unstructured lifetime the usage implies.
Yeah, and that is one of the exciting uses of true closures is to do coroutines, for instance. I think Python does that with generators and the like, but there are a lot of folks who do that. So it's a good thing to do. Fine. So there's one other difference here in how getting at the field values, how you load or call a value in your local variables or identifiers or whatever, and that's polymorphism, let polymorphism. So references to stack frame variables typically get let polymorphism. So here's my two examples. Let it equals the identity function in something. And the AA syntax is identical, except I've, dropped the word keyword let, and the in is just a semicolon, but it's otherwise identical syntax. Sometimes the language will say let recursive for AA, that's baked in. Sometimes it'll say mutually let recursive if you do like a is even calls is odd calls is even, kind of mutually recursive structures, all basically identical, except for how many names are gathered up at a shot when you start defining values. And then for my little example here, length is some primitive, and I just call identifier with every possible thing where I'm just getting the length of ABC. And all it really says is I can pass it an integer, a function, or a string because it's polymorphism, because as a function, it can be int to int or string to string or whatever to whatever. You get similar effects out of generics, except you have to be boxing your integers maybe. And in the case of the standard generics or C++ templates, you name all the things that you're going to allow the mappings between. And in the true typing system, it's actually everybody. It's a for all thing. You don't have to name, you don't have to have a finite count of them. So going on, if I just take my stack frame notion, but I require you to name it and put the name in, then I might say, oh, get it as an identifier for my local variable, but I have to say E because it's the stack frame I'm using. Or I have some random C struct that has an id field, and I just want to load it and use it as a function. Okay. Oh, here's another misspelling. There's ambiguity there. They have identical syntax. And so one requires polymorphism and one does not, cannot, should not. It is incorrect. So back to my main point here, I purposely conflated these two concepts in AA several years ago, quite a few years ago. Because it was just a little less total unique structures in the system, and both at runtime and at typing time, I have a struct thing in AA, which I use for stack frame layouts identically for C data structures. And I also split out the let polymorphism concept from when you load an identifier to a separate node in the SSA graph I'm building for everything. So whether you're a classic struct or a stack frame, I have a field load to get a value, and then I might be polymorphic. And then that's another node in the graph. Hey, Lynn, it's been a long time. Oh, Lynn's still connecting audio. So anyhow, so basically, this was all working. And I kept getting bigger and more fancy examples, and life was good until I got somewhat big enough and I started having weird issues with types that would grow without bounds, and was generally finding that I had cyclic references in my types, which I totally handle except for bugs, which I fixed several, and things were still issues. And I went back to this exe thing I did some time ago, like now 3 or 4 months ago, which I have a simpler core AA language, and I have an execution strategy in there so I can run the code. And I can write the code and run the code, and it looks like AA, mostly minor syntax changes, and it types and it runs, and that's great. And then in these complicated examples, the exe side would give me a sensible same type. And I can show some of these examples here. I should, in fact. And the AA side would blow up in an infinite cycle. And I knew they were slightly different because of what I was doing, where I combined structs and stack frames in AA and not in exe, which had a more classical.
And I think this is why Haskell ended up with kinds instead of types, right? It was to cut off that recursion.
Oh, maybe. I don't know. That's interesting. I allow recursive types, cyclic types all the time because I'm used to cycles and graphs and I know how to deal with them. Fine. And that part's not buggy or not defined or undefined or something. That about all works. So basically during the power outage last week, I dove down into this, and I got a very simple example, which I guess I'll just pull up, that triggers in the one and not in the other, and all has to do with copying in co-recursive structures, copying stack frame types about, and then because in the let polymorphism, the implementation strategy for them is always make a fresh copy of the graph structure and then unify, and the fresh copy is your let polymorphism, because you get all the leaves have new types. So that's how you can be an int in this one and a string in that one. It's because you've made a clone of a bare type variable. And then in this case, the type variable becomes an int. In that case, it becomes a string. Fine. The unification on the other side says the target has to have the same basic structure, but you plug ints in everywhere or strings in everywhere or function pointers in everywhere as necessary. Yeah. Okay. I have an example where this was blowing up on AA and not an exe, and I could look the correspondence between the two down the line, and it boiled down to something happens here that I need to go do, make the exe version blend let polymorphism as instructs, and I should get the same fail or see observe where, for instance, I'm causing let polymorphism on the AA side where I shouldn't, or I should, and that's the issue here. Let me pull up this.
Is it possible that it would help to maintain a back pointer to the type variable that you resolved from?
I maintain pointers in sort of all directions, except, well, okay. There's back pointers floating about in the terms of the stack frames have a pointer to the prior frame. That's not what you're talking about.
No.
Oh, and there's another interesting correspondence there. Let's see, this is not, where is?
Because I'm thinking you could probably also imagine this in terms of a recursive function where the type is one of the parameters. So, you start with an element and then you have a list of an element, then you have a list of an element and so on. So
in these guys, the types aren't reified as parameters as you're thinking of directly. They come in a different dimension, if you will.
Okay.
Let me throw Adrian in the list here. Now, let me go throw the example down here while we're live. I'll come back around to it. So this needs to be, oh, I probably can't do this here. This is me screwing around. It's a little ugly, so it's not a great test case. The key game going on is in this function, which I have written in a way that's really hard to read. So I'll try to simplify, and I don't get any help from from Google here.
Google Max.
Google Max, yeah. And let me do something here. It's probably not a good way to do it either. So the code reads like, make a display, which is a stack frame. Make a stack frame. And I'm making it explicit here because I'm trying to get AA and the exe variants to be exactly equal. So make a stack frame as a struct. Whereas in exe, the stack frames are actually are implicit. They're part of the environment variables from a classic lambda calculus, type lambda calculus syntax.
How broad is this? Does this cover a function or does it cover just certain lines within a function?
Well, when I manually write it, it covers exactly the range from the open curly to the closed curly. When I don't manually write it, it covers exactly how you see it in any sort of ML, OCaml, whoever Haskell language. It's syntactically how they do it, and it's, if you've ever written any of those languages, it's exactly the same syntax. So all this does is make an explicit struct, which I'm pretending like it's a stack frame in my attempts. And this function would normally take the environment variable hidden under the hood. So if you do a SECD evaluation engine, look up the wiki, SECD or SECK evaluation engine, you always pass an environment variable around, and it's bound to a lambda, to a function, piece of code. And the binding of an environment and a lambda is what lets you escape it, but it means this is the state of all my variables for this lambda at this point in time when I make that. Right, so I'm making it explicit here. This particular function doesn't use anything from the environment for some disk is dead and throw it away.
What's the dot underscore?
That's where it gets exciting. So I make a pair of two structs where I am trying to get either.
And does that represent the local variable A and the local variable B?
This makes a struct, not a local variable. This is me attempting to make a struct now, a struct.
But is it the representation of the local variable in the stack frame?
No, it is not. It is intended to be a struct.
Okay.
In Java, I would have said, new A class object and a new B class object. I'm explicitly making a new allocation of a struct with an A or a B. And the dot underscore says, pick one based on the types. And based on the types, it will be unambiguous and you only get one.
So what is pair doing there?
It is because this is the simplified version of the universe. It's not main AA, it's the core AA. I don't have a tuple baked in syntax. So explicitly, it makes a pair of things. It is another allocator, like that says, make me a new A class guy with an A field. Pair says, make me a new tuple of two things. Here's the first thing, here's the second thing. Tuples are primitive. It just takes two arguments and returns a new structure with those two things. The fields for tuple are labeled field 0 and field 1, just like you might imagine on a tuple if a tuple had field names. So if I instead replace dot underscore with dot 0, that would say pull the 0th element out of this pair, which is this new struct with an A equals 1. And if I instead were to say dot 1, I would get the B. And I say dot 2, I'd get a syntax error at compile time saying you don't have a 2 field, you only have 0 and 1. Does that make sense?
Yeah.
Okay, dot underscore says I'm going to pick for you because I'm going to look at all the places where I use this result and decide I'm either referring to an A field or a B field. And way down here in my output, where I say, go to my bogus stack frame struct, go get the bound version, which did nothing because I could get rid of it for the example here. Just run this inner function. Here's the inner function. I'll call it inner function here. Run the inner function and expect to get an A field that I can pull out. And the value of the A field is 1. So I would expect this whole expression to return me a 1 at typing time and at runtime. And here I will get I will say, oh, I need a B field, so I better get a 2 out. And there better be a B field. I get a struct of the B field, I load from the B field, I get a 2. So when I call the bound function, which is really just a pass through to the inner thing I called the inner function, which like somebody renamed me to takes an instance of this. No, I did left the inner function. Yeah, it's still there. Never mind. When I call the inner function in the first context, I get an A. In the second context, I get a B. And that's me doing the overloads. That's my overload resolution. I'm mostly using it for my primitives, but it works in a general way. It's very exciting. It has, now that I've worked it out, a fairly straightforward lambda calculus. Like if I knew enough about doing denotational semantics, I could throw down the denotational semantics for this. Fine. It's just, this was the example that got simple enough that triggered my bug where I get infinite growth on the bogus stack frame, which is not actually used anywhere in this example. It's just being carried along. So somewhere I have a bug where as I do my typing and I'm trying to decide at the first call site to disbound 1, I better come back with a struct with an A. And the second call site, I need a struct with a B. And that goes into how the overloads type. And that goes into how I'm dealing with overload typing. I then get into this funny thing where I keep making, in the Hindley-Milner algorithm, there's a point where you say I have an identifier and I may either take the original type or I take a fresh copy. And I keep making fresh copies of the display, which has a function and a bound variable in it. And inside of them, there's a reference to the display, which was empty. And when I made a fresh copy, it unified and became another copy of the display variable with an empty copy inside of it. And so I didn't close the loop. I didn't hit a fixed point. So I had to go unify again, and I get another embedded display copy infinitely, and I get an infinite stack of them, and it's a bug. And it grows out bounds, and I beat a long time to get a test case that was small enough it would still blow it up on me and whatever. So, wrapping this up, the moral of the story here is I think there's a strong correspondence between stack frames and C structs, and I'm taking advantage of it in AA. And I would like to say I've got more progress on AA, but instead I'm having fun doing typing things that are unexpected consequences. That's sort of the easy summary. And then if you want to know how the hell the display, the overloads work, that's a separate discussion, which I can totally go into. or I can,
So what was the type of the anonymous function with the dot underscore? What, how
yeah,
it's
how's it
typed?
typed?
Yeah.
Okay, so secretly I add a dynamic load table. I'm calling it a dyne table, a hidden variable called a dyne table everywhere. And there's a hidden variable here, which I'll call $dyne.
Mhm.
And this load is dependent upon $dyne. And the $dyne type is different for the two call sites. So in here, I'm going to have a $dyne field I'm going to make. I'll put double brackets for $dyne. I'm going to say pair wants a .0 as your field reference. And here, pair wants a .1. So somewhere passed into bound, which takes the $dyne and passes it along. It gets a $dyne, it's passed in as a $dyne, whatever. I don't have it spelled right. It goes into function, which goes into the inner guy here, and you get this dyne field. Then that just says, given a dyne field in one context, I'm going to get a .0 for that field. And given another context, I'll get a $1.
Okay, but the type is $dyne.
Yeah, the type now
So it's
has the type of a dynamic field in it. So the type here is here, I would colon type. The type is, there are no other arguments. There's a dyne field who takes a field reference, call it pair, and it's going to have an unresolved in it. And then I'm going to return you a leaf. So this function is polymorphic, and the dyne field says he's going to return me a leaf, or the match, the missing match here. There's a match that's missing. Says somewhere in here I'm going to match structs of A and B, and I'll put them in here. I have a match of either A equals 1 or well,
So
B
so does
equals
something end up added into this $dyne every time you use an underscore? It sort of
yes, every
complicates.
underscore in a program adds an entry into the $dyne table, which maps into a data structure, which effectively is a simply nested table that follows the lexical scoping structure of your program. So
Right.
what gets passed into the inner function there is a dyne table which matches the lexical structure of that inner function.
Yeah.
The table has either references to another dyne table, including recursively on itself, or references to an actual load, like the pairs load there,
Yeah.
and then a field name.
Does
And
every
a
time
field
you
name turns into a constant offset at runtime, and basically a easy implementation strategy here is I'm passing the field offset in a register.
Mhm.
And so at runtime, after the pair is constructed, you'd say load from field at base pointer for the structure I just made, the pair, at offset handed into a register given as input.
Yeah. So does every time you add a $underscore make the compilation exponentially more complex?
I don't believe so. I believe it adds a constant amount more typing info.
Okay. So you couldn't write a set solver using just $underscore?
I don't believe so. One of my rules on this was that I expected it to resolve rapidly. Each individual dyne table has to resolve, and they don't get to depend. I guess they get to depend stacked lexically on each other, but not, I think, exponentially at runtime, or though infinitely at runtime. That would be your SHAT solver. As
When you
far
say
as I
it has to
know,
resolve, it doesn't have to resolve at compile time, though.
Oh, it does. Not here at the inner function ends up failing to resolve to a particular choice. It relies on the dyne table, so there's a runtime behavior. However, the outer calls to it, the down here at the bottom I just highlighted, those have to, something has to resolve that is going to get used directly. And I can tell this at typing time. So at the end of my typing, I will only pass you in known values, or I will have an ambiguity error. I can't resolve this.
So the type is resolved at compile time, but it has a runtime semantics.
Yeah, and this is, I won't say it's Cameron saying I'm passing a type about, because it's not as complicated as a full-blown type. It's just passing around which of several choices eventually I'll use at the leaf. And I showed this before with my polymorphic factorial function.
Yeah.
If you created a sort of pair, and then in that there was like another pair and maybe several layers deep, and so that you end up doing dot A, dot B, dot C, dot D, and A, B, C all could resolve either way, and then you finally resolve on dot D. Will it resolve the whole stack of them?
As far as I know, it does, and I have an example buried in my example list that does something very similar to that. In fact, I could probably hunt it up if a little bit of going here. People can look at that. I'll go look and see if I can find this example, because that was one of my. I wonder how bad I can get here.
I almost feel guilty for.
No. These are exactly the kind of questions you should. Here's an example that does something very similar to what you're proposing, and I modified it. I'm going to show the example I have easy. I modified this one. Oops, in the code block. Okay, so I'm going to change the example slightly. Random is return me a 0, 1 randomly, so I can't tell which of my ifs. So at the bottom, going up, Baz, I just call it. It takes no arguments. Randomly, I call bar with an int or a float. Randomly, I call bar with int or float, but inside that, I call function with the bars thing, which is int or float, with either an int or a float randomly. So I either get int, float, float, int, float, float. I get 4 choices. Here I have 4 function choices in a structure, which take int, float, float, int, float, float, da, 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 da. And then which one? Well, that resolves pretty readily. And because of the sharing, the nature of sharing in the Henle-Milner unification style algorithm, I don't believe it goes exponential. I think things just resolve down to, I end up with 4 effective call sites done in pairs, or if I stack this more, I'll get some set of choices here. Right? He'll have to have one of these lines for each of my all possible choices. So that means I'm linear, because I only have to resolve it once per line.
No, isn't this at runtime and it has to resolve all combinations?
At compile time, I resolve them all.
Yeah.
At this call site, I'll pass in a dyne table that says, if the next dyne table chooses left or right, your offset of 0 or 4. And this one will pass in, if the next dyne table chooses left or right, your offsets are 8 or 12. And this guy will say, if the dyne table I'm given is, I pick the left or the right one, and here I pick the left or the right, either the other way. And then when I get up in here, I'll actually have picked out of this, I will have picked offsets 0, 4, 8, or 12. And when I get to here, I'll have an offset of 0, 4, 8, or 12. And I'll just pick the pointer I'm looking for out of it.
So if I understand
correctly, what is the type that Baz returns?
Let me do Theodore first, because he started on my audio first.
No problem. So it's FCN, it's not polymorphic per se, because you don't make a copy here and resolve it by which is the exact typing.
No. I'm using a let polymorphism. I've just pulled out an identifier for function. That's a polymorphic version of function.
But you don't make a copy of FCN, do you? Because
I don't make a copy.
You resolve them as an offset of these fields.
Sorry. Yeah, when you say polymorphic, I'm thinking in the typing system, standard Henle-Milner, if I say function or id, and down here I use it, I make a fresh copy of the type so it can have different different typings for each of its things. But that is not normal Henle-Milner.
But the result is it's an offset. It's not a newly instantiated type.
Let me throw the dyne field in.
Yeah.
Which I'm going to use here at this guy, and that's going to tell me which one. Which means when I call here, I'm passed in another one. Let's call this dyne bar. It's probably not the right one. I should do. Actually, I'm going to modify this one here. It's not. Here we go. But we'll see what happens here. Dying bar. Of course, dying bar is your hidden field, and it's not actually dying bar. It's a dying bar via a hidden lookup here, and this is lookup 0 or 1. And that means here, when I get down to here, the hidden dying field starts here at empty, but I call this guy. I'm going to be passing in a dying field. I'm going to make one up here. So somewhere in here, I have a dying field I'm making up, and I'm passing it in. And this one has offsets 0 and 4, and this one has offsets 8 and 12. And this guy comes in here and says, oh, you need to pick the 0th of either 0 or 4, or pick the 0th out of 8 and 12. So this one says pick either 0 or 8. This one says pick either 4 or 12. So this guy comes up here and has a pick of either, 0, 4, 8, or 12.
Because, okay, in the standard polymorphic function, if you will, here you make a copy and you instantiate it with the result type here.
Yeah.
But here it's not.
No.
Instantiate.
This is from here, and I get a polymorphic change.
Okay.
This is a let or lambda argument from here, and doesn't get a polymorphic change because it's a lambda argument, not a let defined. Which means it pushes its type back to here, which means I've set an offset here, but what I didn't write in is I get a list of choices that I have to resolve against. So I get an outermost dying table that says if I get an int, I have a choice of ints or floats. Oh, this call site gets passed an int, so I'm going to resolve it to the int. This is part of the dying table's typing system. Internally in the typing algorithm, dying table has a unification story that says I have a list of choices. I have a pattern I'm trying to match against. I pick one, and if I can't, I'm ambiguous. If I pick one, then I've picked it, and I unify the match and the pick value, and I also record, oh, you wanted the 0th or the 1st or the 2nd or the 3rd or whichever one. So I wasn't prepared to do a whole giant dying table matching. The dying table stuff's now, I think it's rock solid.
Okay.
I didn't prepare a
because
story.
that's why I try to understand, because there is no instantiating here. You resolve like an offset, like
you get from the call to function, I get some set of choices pushed back at me because of unification. And then this dying table ends up having some set of choices pushed into it, and he's matching against an int. One set of choices comes from here, and one set comes from here. He says, oh, I have an int. And if I do my pattern matching, I discover I have functions that take an int in a second argument position. And so I have to pick them. And so I pick the left half or the right half of the table that came from up here. This guy obviously has a dying table that gets passed in from the top. And somewhere up here, I'm defining a dying table. It turns out it has 4 entries that match QI, QIF, QFI, QFF. That's what ends up in that table. And this will be at offset 0 and offset 4, except he's actually a doubly nested table, so I should double nest him. That's kind of ugly.
So in your example of QFF,
Yeah.
what happens if I make the float case return float?
I will get a unification error when you're mixing ints and floats, and I'll blow up on you and say, hey, you're mixing ints and floats on the returns. And so he'll say no.
So I can do dynamic.
Oh, you broke up really bad, Aaron. Hang on. You're still breaking up. Wow, Discord's doing a bad job. Zoom's doing a bad job here. I'm hoping. No, I see other people moving. All right, are you back? Hey, Aaron, we lost you for like good 30 seconds.
So they all have to return the same type.
I went through the choices there, and I decided that I was going to enforce that.
Because your other choice is dynamic dispatch on return type.
Right. Well, the return would have to probably include a dine table after that as well. So you just went mute and lost your video. We're thinking we're losing you.
Yeah, I'm hoping that I will get better audio if I turn off video.
Oh, I see. Yeah, it did better. And the chat lit up too. I didn't look. Right. At the moment, all are returning the same type. Once I get this stable, I will probably go back and rethink that decision. And see if I can make it happen with variant types. And the thing I have to be careful with is that the code remains understandable, because dispatch where you depend on the return type has been problematic in other languages. People who say, I'm going to do type inferencing and it depends on what A returns, function A returns this, function B returns that. I go either way, but then from A, I go look at his return and go to the next guy. And this is everybody who does automatic type conversions from something to something to something. It's always been difficult to tell which choice the compiler made. And my theory here was, if I just say it has to be the same thing, you don't get any choices on it, and the confusion factor is less. But I don't know. I haven't coded in Anger, so I can't tell. And then maybe that was the tutor. Yeah, it's error. Okay, that was the questions.
Yeah, I mean, the way you cheat that is you make something that returns unit and you pass in an L value.
An L value.
Here's a pointer or a container that I pass in. Mutate the thing in the container, as opposed to using the return type. Would let me sort of emulate having a dynamic return type by just having my
that says I have
final input type
side effects at typing time that change types of values, which I currently don't have. That is, if you have a field in a structure, a C structure, you have a field. The field has a type, and I allow side effects. You can change its value, but not its type. So that denies your cheat. And if I allow you to change its type, I don't know what the implications are. I would probably have to claim I have let polymorphism, and every assignment gives me effectively a new variable that is a struct, which has this field as an int, and the same struct as this field with a string. But from let polymorphism, it's a unique variable.
If it changes type this way, how can you rely, if you assign it to a variable, how can you rely which type is it? So
well, the typing system would come along and say you either get a conflict or ambiguity. But if you routinely, like, you have a local variable, so I see this in JavaScript all the time. You have a local variable, someone's trying to get something from the interwebs, they get it as a string, they call it my variable is equal to some string that came from the interwebs. And then they say, oh, run that string through a JSON parser. Now they have my variable equals the reverse JSON-y of string, and they have a JSON variable. And then from there they say, oh, turn this JSON into a dictionary. And then they say, my variable equal to dictionary of phi of a JSON-y thing. And now they have a thing that looks like a JavaScript-y object, and they go to town with JavaScript things on it.
Okay,
So
that would be
and you can do that by using the variable and the equals sign and just doing assignments.
Yeah, but
can I have a function that does that when I pass in ampersand variable name?
Yeah, each time you do that, you've changed its basic type, which in
that
a typed C-like language would be a no. You can't say I have a string pointer, and then now it's a JSON pointer, and now it's a dictionary pointer.
If you allow that on a local scope, that may be handy, but on a global scope, that's a recipe for disaster.
Well, that was my thinking. I know how to do this in a local scope exactly, because I'll just rename the variables under the hood and do let polymorphism. This is my variable 0, 1, and 2 under the hood, and each is a wholly unique, never seen before variable from anyone else. Yeah, exactly. There's your example in the chat. A == 1, A == fish.
Because it's locally introduced, you can do pretty interesting things without ruining the global scope. So if it's become a global and reference it from multiple functions, that would be a problem.
And then for Aaron's sake, I would map these under the hood. And so uses of A0 here and uses of A1. And this is all fine because I can confirm at compile time that you're not using A0 past the definition of A1 is equal to fish and say, okay, I'll rename it under the hood, give it a whole new type. It's all good.
Yeah, there's even name for that type that has a different types on different times, but they do not overlap each other.
I'm gonna respell it become here.
Yeah, that's what I was asking earlier, Cliff, if it was how it was bounded in terms of by function or by, you know, lines within a function.
The same variable name this is not any part of what I'm looking at up here in this example. So I don't understand your question in my overload example.
Crazy.
In here, this is a field load. It's just at a dynamic offset. And the value from pair is one of several different structs. So it does have different values. So to go to Aaron's question, I am returning different values here. This is true. I give it a polymorphic leaf. It means it's object polymorphism. It has no structure to it.
Why not an intersection type between either A?
Because I'm not putting intersection types in my unification strategy. We could go there if I also started doing that kind of thing. Right now I have classic unification.
Because if you rely on this type, and I still don't quite get what exactly is the type of underscore down here.
Okay, it's leaf. It's
the
type variable leaf. A new fresh type variable.
Oh, okay.
So it has no interesting structure to it.
In Java, angle brackets leaf type.
It's a leaf type object, and Java you call it capital O object.
Oh, okay, it's an object. It's runtime. Okay.
So this returns me an object. Returning from bound gives me an object. Here, I know that in this call site, it's actually typed to be a structure with an A field.
Yeah, because
so the return from leaf is general up there. Down here, it's bound. That's the standard way you get it out of Hindley-Milner polymorphism, where you get a fresh binding of something, and the function here, this diff.bound is a function which returns me a struct with an A, whereas diff.bound up here is returning me a leaf. This is it returns me the leaf, and it's exactly the same leaf that I have up here. It's the same leaf as this one.
Yeah, it would be angle brackets.
So I'll call that leaf, leaf 2, and this is leaf 2, and this is leaf 2. It could be leaf 17, 99. It's the same leaf.
Yeah.
There you go. Okay. Whereas here, I know the function. This expression is it's an application. This expression is a function returning me a struct with an A.
Yeah.
And I know it's a function with a bound up here with a leaf return above, but down here it's known that it's actually returning me an A struct, and this returns me a B struct, and so I know I can say .A on it and .B on it. That's normal Hindley-Milner at that point.
Yes. So the leaf 2 now, it's not the dot underscore. It's not dynamic because it has at least two choices. Why not say the dot underscore dynamic that has to be either A with a 1 or B with a 2?
Right. So I could declare that what I'm calling leaf 2 here has to have one of these types. So you're suggesting that if I go to a union or an intersection things, it's going to be typed as either something with a struct here, A equals 1, or a struct with a B equals 2. It's one of these two.
Yeah.
And I don't want to do that to my current unification strategy typing system.
Okay, that's fine.
Because this with an OR.
This is the only way here, if you match on it, that you can know it's either A or a B. If you
but I don't need to. Okay. I don't need to do it here. I'm doing it only inside the. Whoops, I didn't do right. Only inside the resolution strategy for. Gosh, Google, what's your problem? Only inside the resolution strategy in there. Do I see a list of choices and I have to resolve them one by one? That list of choices comes back to me outside of it as the $dime field that gets pointed at in this context separately from the other context.
Yeah. That's
And then it binds in one to the A and binds in the other to the B.
mhm.
Do the dollar dimes show up in code, or that's just an internals thing?
That's totally internal. It's syntactic sugar. So I write them internally. Of course, it's not a name that you can ever write yourself and you don't actually see it, but there's a hidden extra type variable that's passed along that reifies at runtime to a table of offsets.
Can I pass an explicit type variable?
No, I don't have, it's standard. Otherwise, Henley Milner, there are no explicit runtime type variables.
Okay, so I can't have a function that's like is subclass that I pass in a object and a type
No, but I will probably have an ISA
that's
test,
built in.
which will let you uplift a type from an unknown object to some specific thing. You know, that's
Okay.
an upcast is pretty obvious operator.
Okay.
Is that how you plan to do interfaces? That I define a type that's like has a toString function on it that returns 2, and then I just say is a stringable?
In the land of Henley Milner, everything's duck typing unless I can do a little syntactic sugar behind your back and make it nominative interface, Java interface style typing. Those will type correctly or not. If you want to add a runtime test, like if I just say a thing that needs to be stringable in this context, I'll tell you it is or it isn't as part of the typing inference. If you want to add the test for it, again, it doesn't have to be stringable on the left. After the is a test on the right, it's going to be a stringable and therefore stringable within. That has
Okay. So if
that
I want to
has-
write a function like printline
right,
that
it takes
takes
all these different
anything
things.
that has a toString on it that returns a string,
Right.
I just write printline
No,
print thing dot toString plus new line,
yeah, right. And now print line
and it knows it
requires
needs a
you to have
toString because I called toString on it.
Yeah, so you don't have to say stringable. Anything with a toString will work. Now you can make a named interface type. So all types are interface types, basically. You can make a nominative or named type, and I'll do a syntactic sugar behind your back that says you both have a toString, and also you have this name field, which is a hidden field you can't see, and it has to have the name enumeration in it. And things that are named specifically, I'm stringable, will match that test, and things that are not, but happen to have a toString, will fail because they don't have the stringable baked into their type. So there's a way to both get nominative and duck typing sort of for free in Henley Milner at the little syntactic sugar underneath the hood.
But I only get one name, not a set of names.
Oh, you can have as many names you like there. No, I can set you however many names you want.
Cool.
Yeah, you can start out and say, this guy is meant to be a stringable, and it's meant to be a hashable, and it's meant to be a
Yeah, this is stringable, hashable, serializable.
all those things, right? And all that means is I will check that when you declare the guy that he has it, those keywords in him. But if he happens to be stringable without being called declared stringable, then you could use him in a string using function.
And that is a
but not a function
symbol,
that demands
right?
a stringable.
Not a string.
That's I have these examples floating around too.
So let's say
So-
I have my thing that says you have to annotate
Yeah.
your function as an HTTP endpoint. Do you have to import the HTTP endpoint symbol from my package in order to annotate your thing in that
All right, I'm
way?
going to move my example
Or do you type it as a string?
into a blank. I'm doing an example here with point is a thing with an X and a Y, and distance takes a P and does X times X plus Y times Y. And in this guy, maybe if I do AA syntax here, I would do it this way. And then I call distance with a structure that's a 1, 2. I gotta call it X. Sorry, Google's interfering here. Y. So I can call distance this way because distance just needs a structure which has p dot x. Sorry, p dot x and p dot x and p dot y and p dot y. But I might also have another version of distance too here, which is a function which takes a p, which is declared to be a point, and does the exact same code, which I'll cut and paste here. And then I can say dist2 takes a point object with a 1 and a 2. And this is okay. But if I call dist2 with the same thing I did up there with dist plain, dist1, I'll say error.
What if I put a colon point after that?
That would be an error for the same
And I just
exact reason.
annotate it as being a point.
It's not a point. If you say this expression as it stands by itself is a type error. So let me go make that clear. I've made a new struct. I didn't use the point constructor. It's not a point. Period. End of statement. It's not a point. You get points from the point constructor.
Different packages both define the symbol name point.
Oh, well, then you get name mangling under the hood. It's the full package path to the dot point. So they have different names.
Okay. That was my question.
Okay.
Is
Yeah,
the point is a symbol, not a string. For someone to declare themselves as my thing, they have to import it from my path.
Yes, yes. Same name mangling games you get in every other language on the planet. Yeah.
So if I need the types that's library 1 point and library 2 point, I just import as, and now I have two names.
Right, right. But that's nothing to do with what goes on up here with name changing per variables, which is yet again different from dyn tables and whether they pass offsets on how they're structured and things like that. The thing with this dyn table that I didn't put in here is it depends on the two places where bar is called inside of baz. So it's baz at call site 0, number 0, and baz at call site number 1 here. That might make it a little more clear. And there's two call sites in baz where I call bar, or where I have two call sites in baz, and every call site has to have a dyn table definition type, and so on and so forth. Anyhow, like I said, this part works. Rolling backwards, this was giving me an issue with something.
I wonder to what extent you could use that as a security mechanism.
You could use this as a security mechanism?
If you were careful about who you handed out the point constructor to.
Oh,
you could have a function where you could only be called by someone who you gave the point constructor to.
But that's true of every language that has some sort of security on namespaces.
Yeah.
And they, under the hood, somebody says, oh, make me a new opaque thing that is whatever. Library 1 says, I need an opaque callback. So I make a thing, I hand it back to you under an opaque structure that the type variable system knows that the types are correct on, but the user can't see inside of it. It's just an opaque wad. And then if you pass it back, he gets to lift the type for free and know that he got passed back the same thing he passed out. So he got back his callback correctly. I think that's standard in ML-ish languages, and it's not far off from what you can do with C, but you usually switch to void star or object polymorphism and the guy casts.
I hand you an encryptor. You're not allowed to look at what the key is. If you want to serialize it, you have to come back to me and say, can you please serialize this?
Yeah, the security I was talking about was only goes as far as you don't use reflection on yourself. If there's a reflexive option, if you skip reflection, if you Java no reflection, you'd be fine with library 1 says, I make a new my thingy and I hand it to you as an object, and you can pass it along and you can't reflect inside of it. And if you pass it back to me, I'll say, if instance of my thingy, oh, I'm good. It's a my thingy. No one could have hacked it.
And in AA, because your reflection is going to be based on what the code could have done anyway.
Right. Same security as you would have had if you'd not bothered to use reflection. Yeah.
Same as eval.
Same as eval. Yeah. Well, eval will be that, but that's what eval will get you. What you could have done anyhow. Yeah. Well, that's my AA update. For those of you, particularly Aaron, who's been interested, there's that long write-up at the top of this doc. It's in the Discord as well.
Cool, cool. Any new topic from here?
Somebody asked for a simple update because, and I haven't looked at the code in a while because I was waiting on Diviendu, who got busy. So he hasn't done anything, but I did an update, and let's see if I can go find a version that looked interesting, and it's very simple. And this is like, is this the thing? It's the work list with, oh, that includes the value numbering hash tabling. Did I put the work list there? Where, here's the work list changes. Boom. About as simple as you can get here. Let me do screen share again. So I'm looking at my GitHub desktop. This is simple. A couple weeks ago, and then the Biendu was going to do, he wanted to do some cool hacks, and he got busy, and I was letting him do it instead of me doing the next obvious cool hack. So we haven't stalled for a little while, and I might just push on it simple in my whatever spare time. I owe Cameron a bunch of work too, so I don't know when I get to it, so fine. So buried under here is here's a work list algorithm that simply says iterate through a work list and go until you don't make progress, and then stop, and that's run peoples in a loop. So somewhere under here, there's the iterate guy, and he's saying, pull something from a work list. It can be dead, so ignore it. The count lets me binary search broken peoples, so I can just stop when count equals 123 or whatever, and get the binary search the people that broke things. Run the iter function, which is where I do all my excitement. If I get an answer back, it's not null. If I get a null back, I didn't do anything, and so there's no work list updates. If I got an answer back that's something, then something cool happened. First thing, if it changed, if what I got back was different, then I assume that I'm replacing one node with another. And this is a graph rewrite where I just swap one node for another. And all the people who point out the one now point out the other when they're done. And then the consequence of that is the original node goes dead and gets deleted as part of the subsume call and vanishes from the graph and gets effectively garbage collected by ref counting to 0. Then I take all the neighbors of the new guy, both inputs and outputs, put them on the work list, and I carry on. The progress is there to assert that at each small step, if I have somebody who can make progress, they're on the work list. And as you get peoples that get some large and complicated, when somebody could make progress and needs to go on the list, can get complicated. So it's a nice assert. It makes the algorithm immediately quadratic. So you want to turn off that assert if you're running sort of anything other than a straight up debug mode, because it goes quadratic on you. That was some weeks ago. What else in here? Oh, I restructured people. So people basically calls iter with some known 0 or null. So null or this return is a little different meaning, because people's run at parse time and he can't return a null for no action. He has to return the original guy. And then what was people becomes iter, and iter is going to track progress, and he's going to call the value computation. Am I a constant? What constant value am I? What type am I? As a flow type, not as a Henry-Milner type, which could become a constant. I assert type of is-a. You're only making progress. The type's constantly lifting. I'm improving my type knowledge. I'm going to throw you on the work list if I'm otherwise excited about you. If I found progress because the type's changed, you're going to assert, you're going to claim progress. I still do you're a constant, straight up from what people used to do. It's now inside iter, dead code eliminate, and declare you a constant. And then report progress back or not. And that's like it. Because they cut out the code in the middle. I wonder if I can see it here. Other things, yes. And in fact, the future chapter global value numbering, that shows up in the next push. So idealize your local peoples. Again, if it worked, people your output, and then dead code anyhow, and so on and so forth. Let me go look at value numbering. I think that showed up here, or the next one. Somewhere in here says future chapter goes here. Well, here it is. So first thing happens, I have a cached version of your hash code. If you've not been done before, then I go ahead and set your hash, because the gvn.get is a hash table. It's a standard hash table that he calls hashcode. Hashcode says, "Have I cached hash? No, go compute the hash." The reason it's done this way is because the hash is based on your value, your function at a node. So the node has a function like add, subtract, call, whatever, has some inputs. If your inputs change, and they change all the time due to peoples around you changing, then your hash changes. But if I have a node with 2 inputs and have another node with the same 2 inputs, so they match, the 2 guys are tied, then these are the same node and I can fold them up together. That's value numbering. Common sub-expression elimination by another name. So I compute the hash here, and then I look in the hash table. If I miss, then I put you in the hash table because you're a new thing. And if I hit, oh, I'm going to clear you out because hash is my flag that says you're in or out of the table. And every time I change an edge, I go pull you out of the table before I change the edge, because your hash will change and then your table slot changes and there's the bug. And then I clear the hash code just so I know that you're out of the table. So the rules for going in and out of the table are a little annoying because they're disjoint. Peoples that change edges have to pull people from tables. And I'm going to return the previous guy. The in I pulled out of the table replaces the this pointer, and I dead code eliminate the this pointer. And here's your equals call. Here's your hash code. This is it. It's a new hash map, straight up Java, plain dumb hash map. You have an equals call, which says, hey, true, false. Oh, get a node, look at your edges, do some stuff. And if the edges all match, so inputs are the same, and your class is the same, and your input edges are the same or not the same, you're done. Oh, if they are, everything else is equal, I have to do extra checks, which somewhere in here I get the hash function out of you. Oh, under the hash code. Oh, the hash table calls hash, that's equals. Here's hash code. Yeah. If I have a hash, return it. If I don't, make a hash up. Which checks all your inputs and hashes your node IDs, and that's your node plus function. And it disallows 0 because I'm using that as a key to say you're not in the hash table or you are. So that was a couple weeks ago, and that was a combination of an iterate to a fixed point of peoples, also do common sub-expression elimination globally.
How do you deal with hash collisions? Seems like you don't.
You've got a hash table. You always get collisions in a hash table. That happens. You go to the
But
equals
I thought you're doing a hash and then putting the hash code itself into the hash table, so then you don't have anything to resolve collisions from.
No, into the table goes the this pointer.
Oh, I see. I see. Okay. Yeah. I actually did something a bit differently in mine. I think I'm pretty happy with it, so maybe talk about it, but maybe you'll hate it for performance reasons. But basically what I did is rather than create a hash code, well, I started with a hash code, but I decided that a hash object would be better. So yeah,
I hate you already.
So basically any vector data structure is going to hash, have a hash code, and then you put it in a hash table and it resolves. So what I thought I'd do is I'll take the data that I'm using for hashing, put it into a little data structure, and then use that as my GVN hash object. And then I can, I have a hash that's from that thing when I don't have to do any custom hash code myself to my actual object, rather than sort of doing it just my concern was that I'd have a bug in the hash code and I'd never find it. I'd just have too many problems or collisions that I would mess up.
Right. I did this back in C2 where there were bugs because I didn't throw you out of the table when your hash code changes, which is always when you edit your edges. And I got more hardcore about asserting on it. And when I got to AA, I restructured things a little bit. And that is, the edge manipulator starts by saying, take all my uses, toss them out of the hash table, now manipulate the edge. And the toss out of the hash table is really walk all uses, look you up in the hash table. If I find you, remove you, and I can find that code. But it just made the edge manipulators started with an easy I think I called it un-e-lock in AA. In simple, there's an easier name, but it's un-edge lock. Unlock you, edge unlock you, basically.
Right. Now,
Why is the hash code better than just a random number that's an ID?
The hash code says two nodes are equivalent if they are the same function. That's generally the node's class, Java class, C++ class. Same function on same inputs. And the inputs have a unique ID. So the hash code is same function for the nodes, same edges, done by unique ID.
But you didn't really
Okay,
answer the
that makes sense.
question. I think the simpler answer is that sooner or later, Cliff is going to create an identical, otherwise identical object, different reference, but otherwise identical object.
Yeah.
If he uses the random as the hash code, he can't find the previous one that he created and already registered.
Yeah. So you're parsing Java bytecodes, and you say a sub I, and that says load an I, scale by 8, add 4, add 12, add your base offset, and load the value out. And then later you say a sub I again, and oh look, it's load an I, add 4, scale by 8, or scale by 8, add 12, load again. All those are totally identical, and global value number will pick them up as being totally identical. Load by load by load. Load I matches the load I. Now I have the same load I. Oh, I have add 12 to them both, or add 8 to them both. Oh, it's an I plus 8. Totally identical. Squishes the add. Times 8. Oh, this and this are the same. Times 8's the same. Squish them together. Down the line it goes. It just folds that setup. And that's the reason that's done by function plus inputs. And as Cameron said, Cliff, but every language on the planet gets these things in huge redundant quantities.
but so here's another question. When you're creating your hash code, each of the arguments is each of the inputs to a node is a component of that hash code.
Mhm.
You don't use the hash code of the inputs as the input, right?
No.
You use the ID of
Yeah.
the. So then when you are doing an update, why is it that you have to clear the hash codes of all your
Right.
users?
Okay, so I've thrown in the hash table somebody who's unique and has no other copies in the universe of a node with this edge. His hash is a combination of the node ID and the function here. I'm going to change this edge. So the target is going to change. The node ID changes. The hash changes. You're in the hash table. I put you in under one hash. The next time I ask for your hash code, it's a different number. I can't find you again under the original hash. That's just a broken hash table usage.
Yeah,
You
okay.
can't. Okay.
Oh, right. So yeah, that's right. So it's just your users need to be. Yeah, I must have this because I haven't had this bug. I just forgot about it.
Right. Or you failed and you have many things under different hashes in the same table and they just don't collide with anything. So you don't accidentally pick up an old copy.
Yeah, maybe.
But if you pick up an old copy, it'd have the new edges anyhow. So you don't really care. It's just.
You know why? It's because I used my graph as I didn't actually use a hash table. I just put that stuff into the graph too. And then I would just delete the edge. So I guess that's kind of like zeroing it, but I never bothered deleting the node.
Out of the table.
Yeah, so it's kind of like I cleared the value off the hash. So I basically said hash of some value, it points to nothing.
You have a structure that has your inputs to your hash table. When you change it, that structure changes his hash. You have a hash table.
But what I mean is that if so when I'm looking up maybe I'm mixing something up here, but basically if I have a hash change on an object, I have a node in the graph that's got that hash code and it points to the node that it's it's hashing. So this is basically operating as a hash map. And I just remove the edge and put in a new edge to the newly updated node hash code. So basically like changing my hash, but anything that wants to look up the old hash code, I think I'm talking about a different problem here.
Okay. Well, the other version of that one is no one ever can make the old hash code. So you have an entry in the table who is at a slot where it depends on a certain hash that no one can make.
Yeah.
And then you get in a different kind of bug where somebody accidentally collides, but then they're looking at a node whose hash code doesn't match the slot in the table, but maybe your equals call sorts it out and you don't care. It's fine.
Yeah, that doesn't sound any worse to me than a memory leak.
Right. It's a right.
Yeah.
I mean, it's not great if your compiler leaks memory, but
right.
Most programs are small.
In C2, I had bugs there due to whatever efficiency stupid hacking was going on, where you could get the wrong flavor of something. It either blew asserts or it made it, I couldn't write the assert I wanted or whatever. And so I got hardcore about keeping the table in sync with the edges. And it was always free to throw somebody out of the table and put them on the work list, because the work list, one of the steps is put you in the table. So you just get rehashed and located back in the table again later. And in the interim, somebody else came along who was in fact the dupe, the new dupe, not the old one, because prior change. And then you would collide against the new guy and correctly say, you know, okay, I got a hit. Bugs, hither and yon. I'm certain that there's more than one way to skin this cat too. Like I said, I did a thing on the edge hacks, but I don't have any claim that there's not another way to do that. I want to see if I can find it, but this was like 3 weeks ago, so not in my head. Oh, it's probably under unlock. That's it.
Yeah.
Let me, sure enough. Okay, here it goes. So I'm going to reshare and I'll show you but it's like as stupid, as easy, as obvious as you think it is. So here I am looking at apply Cliff's GVN changes in my GitHub thing. I'm under node, the main guy. The function set def doesn't unlock. Delete def doesn't unlock. Add def doesn't, pop in doesn't unlock. Kill doesn't unlock. Okay, they all do unlocks. What is unlock? Roll down here somewhere. Here's unlock. If the hash is set, it's in the table, remove it. If you have a hash, remove. Oh, you better have gotten it out correctly. Now you're out of the table, done. So every time I do an edge manipulation, I yank you. That's it.
That makes sense. And is that code, that's simple, or is that
That's
AA?
simple. Yeah, that's simple. That's current top of tree. I think it's top of tree simple. Somebody got moved into chapter 9, might be into chapter 9 right now, which hasn't moved back to master, because like I said, Debian was hoping to do something and he wanted to do it. So I wasn't doing it on purpose so that he would do it, and because he wanted to learn, and that was his learning exercise. But I might do it at some point and push forward, and he can go back and look and see what I did, or do it himself and then look and see what I did. You know, that's how you learn something, right?
Your plan for building the book is what? Just run Java doc?
Oh, I don't know. Is the docs are good enough? You know, half the plan is that, and half the plan is call up Martin Fowler and ask him, hey, look at this stuff we got. Can you turn this into a book?
How happy are you with how the code in Simple is looking so far?
I like it. And I've taken some of the stuff we've done and backported it to AA because it looks so much nicer.
Okay.
So it definitely cleaned up.
Yeah. I haven't had a super close look at it, but I've been intending to.
You know, people can argue that I write horrible code or whatever, and I'm very stuck in my ways and blah, 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 but I pick up new ideas all the time. In this case, Debian pushed at me and said, no, we have to have longer names here and there. And no, we have to change this and that. No, okay, all right, fine, whatever. He's doing a lot of work, so I don't want to do the work. I'll do it his way, so make him happy. Fine. And after a while, I was like, oh, that's not so bad. So I picked it up and I went back to AA and said, okay, I'm going to split out all these utilities into separate function, and the core AA node file, dropped by a third. And I put the pretty printer somewhere else, which always gets big and complicated, and it dropped a bunch more, and restructured people and restructured this and that, and okay, fine.
Yeah. Yeah.
I would think Simple's pretty printer would not be that bad. I would expect his to be worse.
It comes and goes, and the one in Simple doesn't have to handle a bunch of things. The one, yeah, you're right. One AA has to handle. So yeah.
Yeah. So I've been doing a kind of overall review, mostly from memory, of how the what it was good and bad in the implementation I did, and because I'm sort of on the hook for a production quality version in
Right.
Less than a year, and so it's a fair bit to do, but I feel like I may be able to pull it off. But I think cleaning things up is important to make that happen. So I was actually thinking might be worthwhile to do a short presentation and sort of walk through learnings and things I did and things that I might want to change. I don't know if people would be interested, but
yeah,
not right now. I have it, but right now I just have reams of notes. So
yeah.
When you do your presentation, we can play the game. Did he learn it from Rich Hickey or Cliff Click?
Exactly.
Okay.
And we'll see how compatible those worlds are. Not completely compatible, I'd say.
Not completely compatible, no. Oh, I like some of Rich's stuff. He's got some good thinking on that stuff. So no problem. It's not necessarily my cup of tea, though.
Yeah. So, and I need to figure out where I'll get the most value from going, changing things or keeping what I've got, or I don't know. I'm kind of right now open to all options.
It's always useful to retrospect any large project and what you would do different and what you would do the same, things like that.
Yeah. So far, I think the biggest, there are a couple of things that are for sure. Maybe I should save it for later, but the biggest one is wiring in all the call sites was like a lot of complexity and very little value. So
yeah, AA has way more complexity than I thought it would for me wiring in call sites as well. And so I put a bunch of complexity into automatically inline during the people stage and the like.
Yeah.
I'm with you on that one. It's kind of like,
Yeah, well, the silly thing is that in the end, I almost inline everything anyway. And so I do huge amount of optimizations on the call sites before I inline, and then I just inline it. So, complete waste of time. And I've come to realize that I could compile each of the functions independently and then transport the information that I've gleaned from doing the functions independently to the call sites.
Yep.
And then save myself a huge amount of trouble. And so this is a change that's definitely going to happen.
Okay.
Well, there's this weird version of call site optimization, which is over inline and then spill. And if you're good at graph coloring and you're good at spilling, then you kind of did optimize the call site by over inlining and then spilling.
That's the C2 plan, yeah. But the other one that I heard him say is take any pile of function description, no inlining, and come up with an IR, and then hang on to that one for a minute at its most IR-like form. And then when I do this other guy, he inlines, or he wants to call this guy, and you want to inline, just take that IR, make a clone of it, and then patch it in, as opposed to reparse the source code or reparse AST or whatever.
Yeah, I would. Yeah, I would definitely do that. But also just like if an argument is unused in a function or something, I can actually just tell the call site and drop the argument without doing any crazy wiring things in together, and keep things much simpler. And if I have a function that always returns a constant,
right, I
can basically get rid of it without even inlining it.
Well, you got side effects though, right? You track.
Well, if there are side effects, but you know, like assuming that there aren't.
Because of you're compiling for this PE array, whatever this embedded systolic array, you probably have a lot of constants returns. It's a less common thing.
Huge
Maybe in your
amounts.
world it's more.
You know, or, you know, there's just a lot of things that I do through a very complicated mechanism that I realize, oh, actually I could do this in a way simpler way. Like, why am I killing myself? And I just don't even want to think of how many months of work I spent on this complexity where I could have just,
right.
You know what, let's do this in a simpler way. But
oh, I started out with a little different. I said I had call sites. Then I had calls to primitives for like add, subtract, multiply, and divide because I wanted to have them as full-blown functions you could pass around and whatever. I didn't like that, so I wanted them to all inline. So I immediately started aggressively inlining them all. And all my typing bugs come about when I have call sites that I do not inline. So I avoided a huge amount of bugs until I had big enough programs that I couldn't just inline shit. Then suddenly the type bugs showed up. And I'd been much happier if I had not bothered, left everything as call sites. It's been horrible looking code, but all my typing bugs have been in my face at the smallest possible program, and I would have gotten them worked out a long time ago.
yeah.
So do you want a no inline flag for your compiler?
I have it now.
You do. Do you have a
Yeah,
note on
yeah.
as well?
By function basis, I can say no inline. I can put it on, if you change a function's name to end in, you know, function underline no inline, he will not inline. He'll call function without an inline. So
someone's going to have a very weird bug one day when they accidentally end a function name with underscore no inline.
Yeah, that's a debug build only kind of thing. It'll go away at some point, but it's convenient for turning it on or off.
So I've been thinking about, sort of change of topic, but I've been thinking about an idea recently related to sea of nodes, which is it possible to do with sea of nodes something like what MLIR does with the LLVM and like move up to higher levels of abstraction with it?
I claim I did the first step of that, and I think it could go up more. So C2 totally tracks counted loops and can find in constant time nested counted loops. And I just rebuild that up from the bytecode format and build it backwards too. When I say counted loop, it means a loop with a compile time known, ahead of the loop time known, lower bound, upper bound, and stride. The stride, lower bound, upper bound are all loop invariant. I mean, the lower bound is always loop invariant, but stride and upper bound are loop invariant, both counting up, counting down, and I can find the nested next most inner loop in constant time from these loops. Now from there to go to, I have tileable arrays. I mean, the arrays in Java make it annoyingly difficult to do, like graph tiling games and the like.
Yeah.
That set optimizations gave me a bunch already though. I did.
So it's like one thing is to go from source and try and figure out what the programmer means. And that's like auto vectorization world or something. But there's another world which says someone is building a neural net or building some sort of high level program where a large part of the program is programmatically generated. So rather than generating source, I'm going to generate a graph of very high level operations, like here's a tensor and here's a dot product against this tensor, and here's, you know, a reshape and stuff like that, and then have that translate directly through sea of nodes peephole optimizations to the basically program that I want.
Yeah. Somebody's talked recently on the internet about doing graph presentations or IR presentations of abstract data types. Very similar. I have an array, but I'm going to do tensor calcs. I have a hash map. It has the following properties. I don't fucking care for 99% of what I do about when you malloc because you got a collision, you had to add a bucket down like as a hash map, it has the property of keys and values. I pull things in, I put things out, things do or don't leak or whatever. There's a whole lot of things you know about collection types.
Yeah.
And those could be done, like finding them is hard from the graph lifting, but getting them from the source coming down, absolutely. So I 100% with you there. I think that's a great idea.
Yeah.
I think it totally could work.
Yeah.
I mean, if I'm coming from the top and I just make a table type and say, hey, program, you figure out whether this should be a array of structs or struct of arrays or array of struct of arrays, like,
Yep.
go build me something that looks like a Parquet file under the hood, because you can tell that mostly what I'm doing is scanning it.
Yeah. Yeah.
Or, and I just annotate it as, this is an analytics table. I'm mostly going to be
Oh.
scanning across it, or this is a transactions
That-
table. I want to be able to make
That
fast
came through
changes
with
individual rows.
the link. Did you put it in the thing?
What's
Yeah.
what's
Yeah.
also easier is in a higher level IR is that you can maintain invariants. So you have an affine loop, for example, and another affine loop, then you can fuse those loops and have another affine loop.
Right.
So a composition of affine loop is affine loop, and this is a concept that is represented directly in MLIR.
One thing that strikes me familiar for the C of nodes is that C of nodes and the C2 compiler, at least to me, observe the types to true values. So it constructs the types only as it's seen through a value. That's that's what I was thinking. So the C2, for example, or the C of nodes only observe the values, and that's why it reconstructs the types. So if it's observe a range of a 2 to 6 or range 12, 10 to 12 or something to something, it doesn't widen to an integer, but it tries to hold on to more to observe the type through the values.
That is not necessarily C of nodes. That is the type that's flowing around,
Okay.
which goes to me doing a lattice type,
Mhm.
and I could lift the lattice type based on local values. And at some point I reversed and started top down with the best choices and fell as I had conflicts until I stabilized. But that has to do with, I define in my typing system integer ranges, so I could recognize an integer range. And I could have done that on a classic IR.
The data collections paper is interesting because it shows cases that are pretty hard to do in a low-level IR. Like, say you have a hash map and you set a key to a value, and then you update the same key to another value, and you would like to common sub expression eliminate it. This is pretty easy to do if you have a collections-based IR. That's pretty hard to do if you have something that is pretty much a free address code.
Right. It's store after or load after store transformations. Because you go through the hash function and there are other stores of unrelated things, it's hard to tell that you're going to get the same thing loaded from your dictionary that you put in it.
I mean, I would argue that's a lot of what enabled the SQL databases get so much better in the last 3 decades, was that people were storing data in these high-level abstractions of a table. And they could really change the physical layout of that data because the logical layout didn't change. If your programming language gives you some nice high-level data structures, okay, is this a dense associative thing? Okay, it's an array or multidimensional array. Is this thing a sparse associative thing? It's like a dictionary. And let the compiler do radical changes to the way it's laying out disk on you because you just made stuff out of dense associative things or sparse associative things.
Right, right. You could also have, a wrapper that counted your operations and changed layouts under the hood according to whether you're doing mostly reads and mostly randoms and mostly writes and whatever.
But only if your IR has those concepts.
Well,
you couldn't do that with JVM bytecode.
You could do it at the Java level. You could write your Java hash table that said if you have 0 entries, I take only myself. If you have 1 entry, it's there. In the one field I have, if you have 2 or 10 entries, the one field points an array of object that has things that I'm just going to linear scan for because there's so few. And if you get a lot more than that, I switch again to another representation under the hood and has the same API as hash table. And you can't tell it apart from hash table, but it's a little tiny bit more overhead for execution for each step in exchange for the size involved scales very gradually from small to large. And
I've
in
written that.
particular, empty tables take up one word of space.
Yeah. I've
And there's
written that
Cameron
down.
saying something.
Huh. Can't hear me? I said I've written that
Now.
one. Yeah, I've written that for all the collection types in Java.
Oh, you have? Well, there you
Yeah,
go.
coherence used it under the hood because that was before the JDK team finally decided to implement the optimization on empty hash maps.
Yeah, it used to be back in the day, a hash map had a default 101 entries.
Yeah.
Nice,
So we
good
found
round prime
out-
number.
Yeah, it does seem like the default should be 0.
In Oracle apps, 80% of the RAM was used by empty hash tables. And we're talking terabytes of
Oh
RAM.
my God. Oh, you probably broke some salesperson's heart.
It was bad enough that we had to fix it. So
Maybe.
then the Java team was like dragging their heels on it. So I wrote the code for them. I said, well, if you won't do it, I'll do it. Sent them the code, which of course they weren't going to take. I knew that. I was just goading them into doing it. And what do you know? The next release had it in there. Not my code. They did a much better job, obviously.
I imagine that at some point, everyone who's going to buy a multi-million-dollar Oracle server installation has already bought it, and then you might as well put the optimization in.
There you go. Yeah, the real cost was the GC time wasted, because nothing fits in cache because you've got these just
Yeah.
yeah.
For what it's worth, I like bug reports that come with code that really explains what it is the person is asking. Even if you don't take their code, it is incredibly helpful to be like, I know with all of the precision of Java code what this person is saying.
Right.
I can tell Kirk wants to say something.
You're muted.
You unmute Kirk.
I'll unmute him, but that might not help here.
Yeah, you don't want me unmuted. I thought strings was a much bigger problem than empty arrays, but
Empty hash tables. They were a problem back in the day, yeah.
well, that's effectively empty arrays. And
Yeah,
there's
I'm
a
not saying
class
Java in
of-
general. I'm saying the Oracle Fusion apps. Something like 80% of the memory usage was empty hash tables, but the strings followed that shortly. That was the UTF-8 internal optimizations.
I've never seen
empty hash tables for broad
I've never seen a heap dump analysis where string didn't come up on top, but array buffer things were always, like number 2 or 3 or something like that. So, but yeah, your app might have been different. So,
Not mine.
Not Oracle, but yeah, Oracle.
yeah. Well, no, it's yours. It's yours. You owned it. You wrote code for it, right? It's yours then.
No,
Cleaning
definitely
up
not.
somebody else's mess.
Python had something similar when they were doing the Python 2 to Python 3, what should we really optimize studies? That when you look across large numbers of Python programs, most dictionaries have 1 or 2 keys in them.
Yeah. Right. 0, 1, 2. Yeah.
Yeah, that's it. Yeah. And it is 0, 1, and 2.
I would have thought the 0 would have been worked out by now, but maybe it's not. Fine.
Yeah, I don't know.
It could be. Yeah.
That I had
Well, so in Python 3, they special case 0. A empty dictionary is a different type than a dictionary with something in it.
What?
So it's the size of a pointer.
Jeez.
I would have had
Benchmark in Java 7, it worked fine. In Java 8, it would run out of memory. And then in Java 9, it would work just fine. They'd gone in and changed the string implementation.
Yeah. Oh, that's right. Didn't they go to one version where they had like a shared common substring thing?
Yeah.
And then if you substringed a vast gigabyte array of XML,
it
would hang on to the base XML array.
Yeah.
All right, fine.
Yeah. That was it. Yeah. That was it. It was a nice benchmark because basically we use it for examples of why you need to test in.
Yeah.
Like,
As some interwebs silly short things that cause with the best of intentions, and it's all interesting government regulation laws all over the world where with the best of intentions they did the stupid ass thing and everyone can see it coming. What immediately follows is whatever stupid thing,
Yeah.
Never mind, it's the same thing. Hey, we'll just share substrings. It'll only make life better. And with the best of intentions, we hack the JDK. Promptly like, oh,
I
Yeah.
put a link. I
Wasn't
put a
always
link
better.
in the doc, by the way. It's hilarious. That's actually predates the. That was from '99.
oh, inflatable map. Excellent, excellent. I have long thought about doing something similar. And when I do my own things, I do stuff like when I did the non-binding hash map. I think I set my default table size, had room for 1 key, not 0, but 1. Something stupidly small. Thing.
You'd have to think about all this stuff for the standard library in AA. What should dictionary and array look like?
Yes. That's not yet till I get the typing done, but maybe typing.
I mean, I think getting those basic data structures that are by default grab these, right, can make or break a language.
You want a reasonably good standard default choice. You're not always wrong if you grab the default.
I do wonder how good it is to make thread safe default choices. Because there really is some overhead to making everything thread safe, but maybe your map should be non-blocking hash map by default.
It's a horrible idea.
Why?
To make everything thread safe by default?
Yeah.
Data structures, yeah.
I grab you non-blocking hash map for your hash table. The overhead for it versus a normal hash table is really tiny.
You know,
So one of the bugs that actually I was in Heinz Kitchen when we tore that one apart. We figured out was when you get, it was JDK 8 when we found it, but what happens is you get like a hash map resize while a read is taking place where you have a collision going down the collision resolution chain.
The infinite loop.
And the resize reverses the collision resolution chain. Pointer gets hoisted, so tail goes to
head. And you get infinite loop. I've
right,
been there.
and then so there's nothing in there that basically takes the pointer out of the register. So the point is in the register, and all of a sudden it's pointing to the head instead of the tail or whatever. So it gets flipped around, and so your thread just keeps going like.
Right.
And
we hit that at Azul on a large 3-letter company's name's favorite web app server major product.
Mm-hmm.
Some clever guy was catching array index out of bounds, calling a hash table with no synchronization, hash map with no synchronization, catching array index out of bounds that happened occasionally during a resize, catching, I want to say NP, he had one other catch that only happened very rarely. And then because Azul did way more aggressive GC things, we would periodically hit exactly that bug. That thread would spin forever. Because it spanned forever, the transaction would time out. The timeout manager would launch another thread, but he wouldn't kill the old one. Because you're on an Azul box, you had hundreds of cores.
Yes, you wouldn't notice it.
The same transaction would die again.
Yeah.
And it would gradually eat a new thread and a new core spinning endlessly every timeout moment, every 30 seconds or whatever. And so over a while, your throughput would just start to tail off as more and more cores were running. And then you start load sharing on the cores, and more were spinning on the same cache line, spinning through the same infinite loop.
Interesting. Because in this case, like on the smaller core counts, like maybe like 24 cores or something like that, you would just lose the core, because generally it would take about more than a week of continuous production for it to show up, right? Get the right conditions.
So after a while, they would gradually lose cores, but more gradually.
Yeah, you'd lose a core, right? But then you'd be very unlikely to lose the second one.
Okay, because you reboot the machine, I guess.
Well, no, the conditions would just be different in the runtime. So as you start reducing cores, and the odds of getting 2 threads in that condition at the same time, probabilities just go like from,
Azul hit it
close to infinite to closer to infinitely impossible.
Right.
Yeah. I mean,
it sounds like the difference with Cliff's bug, though, is that it left a cycle in the hash table.
Yeah.
It sounds like yours, you only got into that infinite loop once, but you didn't leave it in the hash table.
Well, you get into the infinite loop because the pointer gets hoisted into the register and never gets refreshed, and because you never get through a barrier, then nothing gets flushed. And if it did, then of course the whole thing would self-correct. Because you would reach the end of the collision chain instead of being flipped back up to the
you were spinning in registers.
But you're basically spinning through the collision chain.
Yeah, I'm pretty sure we ended up spinning through the loop was actually written out in the heap. But different, so it could have been just a different instance of a similar operation, different way the compiler did the code even.
Yeah, I don't think the pointer value got printed out to heap.
So the other major data structure I think of that would be safe or not would be an array list, which is typically not thread safe. And should it be thread safe by default? And what's the overheads involved?
I mean, if array list append and array list pop were thread safe, I think a lot of people would just accidentally write safe programs.
No, that's the lie. That is completely the lie.
Yeah, exactly.
Because the problems are logical. And fundamentally, by pretending things are thread safe when they're not, you're just making bigger problems.
The bug's still there; it's just harder to hit, but you'll hit it.
It's just more expensive.
It's more expensive, right? Because
so the copy on write array is an interesting one, right? Because it's supposed to be thread safe thing, but if you look at how it gets compiled, it's actually thread safe, but it doesn't do a copying on write on every write.
No, it should only do it on the first bogus write.
Right, but you would think by the implementation, the Java implementation, that it's like on every write, you're going to get a copy.
Well, that sounds like a bad implementation, but I haven't looked at the Java. I didn't know such a thing existed is in the standard JDK.
Copy on write, yeah, exactly. So it's a thread safe array, right?
Yeah, okay.
So in that case, but the compiled implementation is quite different than the. I mean, the JIT compiled implementation is quite different than the Java code.
Oh, is the JIT cheating? They do that.
Yes.
I mean, I do that.
Yeah, of course. So you get an interesting implementation of the data structure that actually doesn't do a copy on write, even though.
Well, you want the
Java
copy
code
elision to get rid of 99% of the copies of your copy on write data structures.
Right.
That's interesting. Yeah, I claim that's another. I'm with Cameron here. There's semantics that are weird enough that if you're using it on purpose, you probably know, and you would do something. You could implementation-wise do something different. And if you're using it by accident, you almost surely have a follow-on bug because you'll miss the updates from the other threads.
Right, because of all the tools that we have in terms of composing software are non-composable in concurrent land, and that's the problem. Yeah. Is that we think about ++ X, right? Well, it's not composable. Like we have CAS, so we do have composable things like CAS, but again, you have to start from the ground up and build with composable pieces.
Yeah.
So array list itself is not a composable concept, nor is fundamentally concurrent access to mutable data structures, even if they are defensively, synchronized or CASed or whatever. Concurrent access to mutable data structures is something that only about a dozen people in the world know how to do correctly. Sorry,
no, we don't have to do it correctly. You just put a full-blown set of fences around it, right? Lock it up so hard that only one thread gets through the time anyway.
Of course, you will run into deadlocks, and that's why everyone has to write a lock-free atomics.
No, it's a harder problem than that. The lock-free atomics is great, but it's not.
I may or may not have been serious.
He may have been sarcastic.
Okay,
I think he was yanking your chain.
That's my autistic thing kicking off. I do not recognize many other people's emotional here's a joke. Oh, okay, missed. I'm too much the straight guy. Fine.
But this group is so good at emotions.
I know. Oh, geez.
It's similarly to how you can avoid undefined behavior in C and C++ by just directly writing assembly. It's pretty simple.
Yes. Then you're not writing C code. Okay, that joke I got. Fine.
I mean, that's how I avoid undefined behavior in C. I don't write in C.
Don't write in C. No problem. Oh. What the hell? The whole
Doesn't
undefined
save me for
behavior
undefined
thing,
behavior in Rust, but that's fine.
when I was coding Hotspot 30 years ago, like, fuck, no one cared. Oh, it was obvious, different hardware, different rules, whatever. You knew it was going to be different. No one cared. And there was a standard. Yes, it's technically undefined, but boy, if somebody did anything other than this, they were fucking nuts, and their compiler would get shot. So it was technically undefined and practically well-defined, like two's complement
Was
of
it like
arithmetic.
looping
I'm not
around
running.
a signed integer undefined
Yeah,
for
right.
a long
I'm not
time?
compiling to a Honeywell one's complement machine. I'm not making Hotspot run on a Honeywell one's complement machine. Okay, fine. Now it's all two's complement. All your undefined behavior about ones versus two's complement just went away. Fine. These days, it's very much there's a lot more noise going on about it, which I guess is good.
I mean, the noise about defining a memory model certainly helped.
It did. Yes, it was undefined and no one cared, and then we cared. And then there was like, only the mainframes and supers hit multi, 2-core, whatever, and then you could get one from Fry's. And suddenly you cared. And suddenly it was different from either I got a compact motherboard or a Dell motherboard.
Or in your pocket.
So
well,
we
that
had,
happened later when the phone came around.
Before-
I'm talking pre-phone. We were already well knowing that it was sick pre-phones, but yeah, now it's in your phone too. So, but the time the phone came around, we knew that we had to do something, and that I'm going to say Dalvik or whatever Google was doing was already being careful.
Before Doug Lee was out with all his stuff, we had customers in production on pretty big parallel Sun machines and IBM machines and whatnot. And at the time, we couldn't afford one for the office. So all of our testing was done on single CPU machines. And then Geico.com went down because of our software, because of the concurrency bug. And, this is, we had their software, we were running it in-house. We could not reproduce it. And finally, we found someone who could loan us some remote cycles on a multi-CPU machine. We could reproduce it inside a second once we,
Wow.
once we had access to a multi-CPU machine, it was like bang.
At least at Azul, I had with a smaller box nearby, I could lay my hands on a little box.
Yeah, it's a little bit of cheating though, having 1,000 core machine is a little bit different than what I was.
Yeah, the little box only had a couple hundred, but still. All them concurrency bugs came right at you. They weren't long coming. Fine.
Yeah.
And now, now my phone has like 8 cores.
Right, and you can get 100 pretty easy. Fine.
Crazy.
Let's still go back to your line. You get 1 core, and when you learn how to use that, then you can have a second one, right?
Yes. Yes. Well, you get 1 run with your punched cards through the operator mainframe once a day. If you wanted 2, they looked at you funny. What's your problem? You were stupid. You didn't do enough work the first go around. What the hell? I was on the other side of that one, not the operator side. So I was on the losing side of that one for a while. Fortunately, I was a young kid, didn't know better, didn't care better.
I've seen a punch card.
So,
for the longest time, I kept my old Star Trek game as punched cards. It's stacked like this of punched cards. We played, old teletype style Star Trek game.
punch cards, yeah. They're horribly.
Yeah,
heavy.
my mom's got a box in the attic with her Fortran code punch cards from her thesis work. And
yeah, I think I still have slides, transparencies from my thesis work. They actually start to stick together after a while. They've been compressed for so long.
So put on a YouTube video, I was showing my kids something a while back, and they're like, what is that thing? It was an overhead projector. They'd never seen one.
Never seen one. They were de-rigger in my high school classroom and beyond.
I remember when they came out with the coolest thing where you could put on top of that, you could put the LCD thing and it would project from a computer.
Yes. Yes, I remember those.
That was just
the risk of being fourthy and combining 2 things on the stack. I wonder if our question about safe multi-threaded data structures and our question about putting the data structures and common operations into a mid-level IR could help solve each other. And say, okay, here's common things you want to do to tensors.
Right. like,
I'm gonna go tile the thing and spin off a whole bunch of threads and
Yeah.
come back to you. And
I claim that you have to go high level to go concurrent, but wherever you slice and say, and here is my level, if I go down, I can add concurrency in a way that you don't see it, but is useful. But if to go up and add concurrency is really hard. So you want to start with concurrency in your language if you intend to be concurrent. Because otherwise,
I
what
want
you just
big
said
auto
was,
tileable
right,
data structure.
this is the H2O model. I bulk synchronous parallel. Here's a big pile of data, and here's a pile of operations. Go to town. Well, that's the level I took it at H2O. Just parallelized under the hood. You never saw it. Yeah, done.
And that's probably both a memory model and a disk model. You want to be able to say, here's my big thing that's bigger than memory. Can you spill these so I can actually save a data set?
I dodged the disk question at H2O. So you could
H2O
argue
was
that
if you don't
didn't
have enough
solve the
memory, you can't
database
process
version.
the data set.
I'm sorry?
H2O was don't process data sets larger than memory.
Yes. Now it had to be larger than memory after compression, and compression was really good. But yeah, only in memory. So, but your typical gzip, we would be 1/2 to 1/4 the size. So as a disk storage space, it would have been a really good solution for a lot of these data sets. People who were stupid about storage, we would be 1/10 the size in memory.
Yeah, the other thing is things are much different now because of Flash, because Flash has no concurrency penalty on reads and writes.
Yeah.
And what I mean by that is databases used to schedule all their writes. And in fact, Apple spent years on the OS side doing some low-level library to do this as well, because once you get the head in the right position, you could hit, even on a spinning hard drive, you could hit 300 or 400 megabytes a second writes. I'm sure Kirk will correct my numbers, but I mean, pretty good streaming
Sounds
writes.
right.
But if you had to move the head, you paid 15 milliseconds for the head move. So if you had two writes going on and you're moving the head back and forth, you could go from 300 megabytes a second to like 0.5 megabyte a second.
Yeah, it'd be a huge reduction. Yeah. And that was databases, one of their main claims to
And we
fame.
saw this with some of the DNA stuff that was done on coherence, where they used our disk capabilities, and then if they had failover, what would happen is they'd have to pull backup stuff off the disk to redistribute across the cluster, and that was interfering with the stuff that was running, and so they might have a 4-day failover process instead of what should be 100 milliseconds, or I don't know, I'm making up numbers now. I don't remember.
Right.
Yeah. So we had at Gemstone, we had a object database, so it's like orthogonal persistence. Right? So basically, very funny. Where was I? Never mind. Next story.
Object persistence, yeah.
No, I was kidding. We got that.
Oh, you were messing with me.
Yeah, I was messing with you. Yeah, exactly. So so basically if you were rooted on a persistent route, and the garbage collector would just move you off into some space, you get put onto a page, and who knows where it all went. So access to jumping through pages, especially if they're using.
Was that Gemstone S?
Terrible. And J. Same mechanism under the hood. So we came up with a data structure that was called a cluster bucket, and the cluster bucket actually gave a hint that basically said anything stored in this cluster bucket, which is effectively a big hash map, put it on the same page. So keep this physically packed together on the same page, just to solve this, like, let's not jump around on disk problem.
I have some history with Gemstone from the Sun side that I'll catch you at J Creed. It's minor stuff, but there was an episode or three.
Three.
Yeah, somebody came to me at Sun from some company called Gemstone I'd never heard of, said they were trying to get some Java optimizations done.
Richard?
And I don't know who it was. And I said, oh, do this or that, and I helped them write their code a little bit and organize it. And they were very happy. And then about a week later, I got a chewing out from a Sun sales guy, maybe, that I had helped his competitor, Gemstone. And I was like, some guy asked for help. I gave him help. I'll give you help if you ask. And he never came back to ask. So I was trying to figure out what the hell was gemstone and who were they competing with and why did
Oh,
somebody
yeah,
care or not?
Yeah, we had so these guys had built the Java virtual machine effectively. They'd taken something from Sun and then basically wedged in this whole persistence layer in it. So you had the orthogonal persistence on it, right? So
Right, there
again,
was a hot spot and they were hacking it. Yes.
yes,
That sounds familiar.
yeah, because we had to do all kinds of weird things because keywords like transient now become meaningful because if you persist it, then the question is, what do you do with the transient stuff, right?
I still had the same issue, yeah.
So if it goes down to disk and comes back up, it gets stripped off. But if you're still in the same runtime, the transient's still valid. And it's like, it was just anyways.
Yeah.
Okay. It was fun. There's all kinds of fun. I don't think anyone uses a keyword transient anymore, do they?
I still
So you
use
could
it
delete transient at any time for any reason.
I'm sorry?
I use it as a comment.
Okay.
As a
Hashcodes
comment.
said, don't
Your
pass
comments
this.
are transient?
Yeah.
No, I use the keyword transient to comment that this is a part of the object that could be thrown away and reconstructed, basically.
Right.
Which is what it was for serialization.
Right.
Yeah, sure. Absolutely.
And H2O used it to mean when passing this across the cluster boundary, we could lose and rebuild it for exactly the same reason. Yeah.
Yeah. Okay. Yeah. Well, we had to deal with people using transient in, shall we say, not so structured ways. They're going like, here's a keyword. Let's just see what it does.
Well, the interesting thing is
Literally
transient
code
was in there before serialization was in there. And volatile was in there before the memory model was in there.
Yes, I remember that.
Yes.
Well, there was an intention on volatile to do the right thing. They just
And there was an
didn't have the right
intention on
thing.
transient to do the right thing.
But what was transient for? Who was using transient? Why?
Well, I mean,
It was
like
for
if
serialization.
you had a file handle, right? I mean,
Yeah, right.
it makes sense in
But only if you're serializing before serialization. So manual serialization.
But-
Oh, curse. People
but
manually serialize.
effectively,
Yes.
but effectively, the orthogonal and persistence doesn't serialize, but it does because we're just taking the data and putting it on the page, so it's still inflated. It never goes through serialization, deserialization. But the point is that if you persisted it and sometime in the future brought it back, or well, even worse, right? You could use the persistence as sort of like a distributed cache because I could have multiple JVMs hooked up to the same underlying database. So this is a way of actually getting, well, we didn't need things like coherence because it was sort of like built in, right? And you didn't have to worry about all kinds of things you have to worry about with OR mapping because it was like built in.
Right.
So
Well, it's a shared everything model, which is the opposite of where we went. So
yeah, sure. Right. So you don't have to worry about things like keeping copies coherent, right?
Yeah.
Right. When you've shared nothing, there's not much to keep coherent.
Well, yes, exactly. But that was the point because you weren't actually sharing a copy. You were sharing in a like shared memory space or whatever, unless you had distributed across machines. And then, anyways, then you end up with all kinds of other problems.
All right. I'm looking at winding down.
Really?
Yes.
Start going.
I know you just got started, dude, but we're at 2 hours and change now. So I'm thinking it's getting time.
We'll save my updates for next week.
Yes. All right.
When I get Gradle working.
Yeah.
Oh God.
You haven't been washed off the side of the hill, have you? There, Cliff?
Oh, we had 70-mile-an-hour winds.
Last year was off the side of the hill.
80. This year was only 70.
Oh,
it
okay.
blew down one of my large farm gates. So I'm out large.
That's like a weak hurricane. So
yeah, boy, it howls. You can see the glass doors vibrating in, like they're pushing in significant fraction from the wind force.
Cliff needs
been in a
fence
couple of hurricanes.
Large, heavy grills were walking across our deck and heading for the fall downstairs.
I said that Cliff needs a fence instruction.
Yes, I need a fence instruction. It makes me a fence.
Well, I heard there's some atmospheric rivers going through there. I mean, we had one here a couple of years ago now, and it took out every road between here and every place else. So for a couple of months. You could only get it in and out.
Sounds familiar. We had one of those both last year and this year. So this year's wasn't so bad because last year, all them trees that fell mostly already fell.
So,
This year, new trees fell, but I think fewer than last year.
okay, that's sounds like the problem is going to fix itself over time. And now the reservoirs are.
Oh, last year they all filled up except maybe one or two. The biggest ones didn't get maxed, but now they're all maxed. Yeah, we're solid on rain.
Okay, so you guys can waste water again.
No, California learned the 20-year drought was trouble and we got ready. And the rains hit big last year and we were ready and we caught a lot of rain.
So we just decided
California-
to
Yeah, we just
delay
have to
the-
make it last for 20 years.
And you have
Is
yeah, right,
California
exactly.
pumping water back down into the water table, which they completely depleted? Isn't the
there's no-
Central
the
California
belief
like a foot
is-
lower than it used to be?
Yeah, the Central Valley water table, the stone compresses measurable amounts, and there is no way to get the water back in.
Yeah,
The
it dropped
mineralogy-
At least
33
not
feet.
without causing lots of earthquakes.
The
I don't-
land itself has dropped 33 feet in most of the valley.
Yeah. it's
33 feet. I thought
33 feet.
Yes, it's crazy.
Yeah.
That's like 10 meters.
Yes.
Wow.
Yes, that's probably what it was based on, was 10 meters. So, but translated into American, we called it 33 feet.
Oh, I don't know what a foot is. but
Oh, and we have a
most of
new
the county
lake.
in your lake. Hmm?
We have a new lake in Central Valley, a new large lake. Back 100 years ago, Tulare Lake was a thing in the low end of Central Valley.
Oh,
And people drew water out for farming and they left a bunch of irrigation paths and dikes and ditches and it ran out of water and then they decided to farm over it. But they knew it was a low spot, so they kept it as farming only. And last year when the floods were coming through and like Lake Oroville overflowed and the dam was washing out, they reversed all these dikes and opened things up from 100 years ago and they refilled Tulare Lake.
oh, so it went from farming to fishing.
It went from, yes, it had been fishing and then it went farming for 100 years and now it's fishing.
Back to fishing again. Yeah. Old becomes new, new becomes old, right?
Yeah, you go look up Tulare Lake, you can see that it's fun to watch people talking about it and watch it.
Where's that at? It's
Southern Central California. Go look up Tulare, Tulare. I can link it here.
Okay, yeah, no, I'll look it up. That's fine. I just thought you might name something. Or
So is it something
well,
they're planning on
yeah,
keeping
Lake-
around,
yeah,
or are they
there
going to
you
drain
go.
it back out?
You just go
Explain.
search for TLARE Lake. Let me go put that in the chat if I can get the. Google's trying to show me all kinds of things here, not related
Yeah.
to anything.
is it,
Refill the lake, hammer the
It doesn't-
spheres back into plowshares. It'll be great.
yeah, if there's no sponsor for that lake, it's not going to show up in any Google results. So
Oh no, it searches immediately. I did Tulare Lake. Spelling is in the Google Docs. TULARE. First hit, boom, pictures, videos, all kinds of stuff. Just pops right up. Because it's a large freshwater lake that hasn't existed for 100 years. That suddenly is back. It's kind of a wild, crazy thing.
and no one's upset about that, right?
Well, your options were drown elsewhere in the major cities with massive overrun flooding, or take this farmland, which had been set aside in case of overrun water, and dump the water there. So that's what they did. It had been set aside
I'm
for
sure
just
there are
exactly
lawsuits.
this thing. I'm sorry?
There's got to be
I'm
lawsuits.
sure there are lawsuits.
Yeah.
There are always lawsuits, but that doesn't mean, I mean, it's going to be hard to say you didn't know about it because that was all requirement going in.
8 times 10 to the 9 cubic meters of water. Yeah, it's a small little lake.
Uh-huh. It's some numbers of miles across. There you go. All right. Something for everyone.
Coffee
to go read
Compilot
on.
Club. We cover data, we cover lakes.
Yes.
We didn't talk about data lakes.
We got to figure out how to compile our data lakes.
Yeah, exactly.
We talked about fence instructions
No, and fencing. Yes. Jeez.
and gate failures.
Somebody blew down my fencing, blew through my fencing.
Yeah.
All right, done. Till we meet again next week. Bye-bye.
All that water in Southern California. Imagine that. Ciao, guys.